Hello, my name is Douglas Pearce-Price. I'm working here at the ESO headquarters in Garching. At ESO, an international team of scientists and engineers builds and operates some of the most sophisticated scientific instruments that humankind has ever seen, and it all comes together right here in Garching.
ESO is Europe's intergovernmental organisation for astronomical research. Supported by at present 13 member states, it operates research facilities on 2 continents, Europe and South America. In Europe we find ESO's headquarters. Located in Garching near Munich, it is the scientific, technical and administrative nerve centre of an organisation whose task it is to develop and operate some of the world's most advanced observatories in support of all scientists in its member states. The headquarters is the home of a large science archive, which comprises scientific data obtained not only with ESO's telescopes, but also with the Hubble Space Telescope. The data are available online for scientists worldwide. On average, almost 100 gigabytes of data are requested from the archive each day, all year round. At the ESO headquarters, support astronomers also help their colleagues in the member states to prepare new observing programs. Before they can be carried out, these programs are not just subject to rigorous quality control, but are also competing against each other. There are 5 times more proposals than can be accommodated. Only the top proposals are finally selected for observation. Astronomy is heavily dependent on technology, and ESO is engaged in an impressive program, constantly improving the performance of its current instruments, as well as developing new instruments and techniques. In fact, ESO's instrument development program is probably the most ambitious in the world today. Also at Garching, concepts for the next generation of astronomical telescopes are being developed. Thus, plans are made for telescopes and instruments that may be ready to use when some of today's school children are about to leave university.
It's exciting to work here at the ESO headquarters. Still, the most fascinating aspect of ESO is its observatories, located in the Chilean Atacama Desert, 12,000 kilometers away, almost as far away from Garching as you can get.
The Atacama, the driest place on Earth. A stretch of land with practically no precipitation. Few species can survive this harsh environment. Of all places, this might seem the most improbable for one of the world's most sophisticated research facilities, the ESO Observatory on Paranal. Yet it is precisely these harsh conditions that make Paranal an almost ideal site for astronomical observations. The sky is clear almost every night, the humidity low, which is necessary for certain types of observations, and there are no nearby towns with streetlights to cause light pollution. Paranal is a 2,600-meter high mountain. The mountain top has been flattened to create space for a suite of telescopes collectively known as the Very Large Telescope, or for short, the VLT. At the heart of the VLT are 4 telescopes, each with primary mirrors of 8.2 meters diameter. Standing 24 meters tall and weighing 430 tons, they're among the largest optical telescopes in operation today. Each of the telescopes can be fitted with several advanced instruments, such as spectrographs and cameras, which the astronomers need to capture the faint light that arrives at Earth from celestial objects. The VLT makes extensive use of key technologies such as active optics, which was developed at ESO in Garching, and adaptive optics, a technique to overcome the adverse effect of the Earth's atmosphere on starlight. With adaptive optics, telescopes on the ground can see as well as if they were in space. Even sharper images can be obtained by combining the light from several of the main telescopes and a number of smaller auxiliary telescopes. So the VLT is turned into a giant interferometer, with which it is possible to observe the shape of stars which are 1 million times further away from us than the Sun, or to probe inside planet-forming disks around young stars. Maintaining a high-tech facility far away from civilization and in the middle of a desert is a major logistics challenge. In order to guarantee the supply of water for the observatory, special trucks have to transport this valuable resource on a daily basis over a distance of some 120 kilometers before it is put into storage tanks. Moreover, Paranal has its own power plant, which generates the electricity needed to run the installations. The generators are checked at regular intervals to avoid malfunctions. Catering plays an important role too. The kitchen staff constantly serves a wide variety of fresh food. The observatory must remain open 24 hours a day, all year round. The days are reserved for maintenance, instrument upgrades, calibration and tests, while during the precious night hours, the telescopes are all pointing towards the sky, looking at objects so distant and faint that no human eye can detect them. The VLT plays a major role in literally all areas of optical and near-infrared astronomy. It has made major contributions to cosmology, the study of large-scale structure of the universe, by enabling observations of galaxies as far as 13 billion light-years away from us. Their light has traveled through space almost 3 times longer than the Earth has existed. In our galaxy, the Milky Way, the VLT has enabled precise measurements of heavy elements in stars, and thus helped verify the age of the universe. It has carried out detailed studies of the inner regions surrounding the black hole at the very center of our galaxy. Here we witness the spectacular movement of a star only 17 light-hours away from the black hole as it is being pulled towards the hungry monster. The VLT has also been able to probe deep inside the center of another galaxy, showing for the time network of filaments that channel matter from the outskirts of the galaxy down to the center. The VLT also discovered the first triplet of supermassive black holes lying more than 10 billion light-years away. Closer to us, the VLT discovered the first triple asteroid in our solar system, the rubble pile minor planet Sylvia, and her twins Romulus and Remus. More recently, astronomers working at the VLT obtained the first optical image ever of an extrasolar planet, a planet in orbit around another star. Such planets have been known to exist for the last 10 years, but until recently they could only be detected by indirect means. Searching for extrasolar planets is also a speciality of ESO's other site at La Silla, 500 kilometers south of Paranal. La Silla is a 2,400-meter-high mountain and the home of several modern, medium-sized telescopes, including the 3.5-meter New Technology Telescope and the 3.6-meter telescope. The 3.6-meter telescope is a classical telescope, but it has been upgraded and today features what is probably the most advanced spectrograph in the world. With this spectrograph, it's possible to measure minute deviations of stellar motions, strong indicators of the presence of orbiting planets. Very recently, the smallest known exoplanet was discovered. Moreover, the 5 Earth-mass planet lies at the right distance from its host star for water to be liquid. It is thus the most Earth-like planet ever found.
The telescopes at Paranal and La Silla are used to observe the visible light and infrared radiation that is emitted from the stars and galaxies. But celestial objects also emit other kinds of radiation, such as radio waves and what astronomers refer to as millimetre and submillimetre radiation. To study these kinds of radiation, scientists need to use a different kind of observing device, and they need to go higher.
ESO's third site is a high-altitude plateau named Chajnantor, close to the Bolivian and Argentine borders. At 5,000 meters, ESO, together with partners in North America and Japan, is now preparing for the installation of a huge array of parabolic antennas, each 12 meters in diameter. The antennas are movable and can be arranged in a number of configurations across an area of 18 kilometers in extent. The project is known as ALMA, the Atacama Large Millimeter-Submillimeter Array, one of the largest international projects in ground-based astronomy ever undertaken. While observations will commence earlier, the construction phase is expected to end by 2012. But even now, astronomers are active on Chajnantor. Using a modified ALMA prototype antenna, the APEX telescope is already collecting important astronomical data. APEX stands for Atacama Pathfinder Experiment and is a joint project between ESO, the Max Planck Society in Germany, and Chalmers Technical University in Sweden. With observations at wavelengths of the order of a millimeter, one can investigate galaxies which are just formed in the very distant universe. Also, one can study the birth of stars and planets deep inside dense dust and gas clouds which are opaque to visible light.
While ALMA is now under construction, ESO's scientists and engineers are planning their next-generation telescope. It will be a giant optical telescope with a mirror that could be as large as 42 meters in diameter. For now, we call it the EELT, the European Extremely Large Telescope.
Everything about the EELT is gigantic, except for the price. With the VLT, ESO has already used new methods of telescope design and operation to reduce cost. For the EELT, ESO has developed a revolutionary approach that will bring down the construction cost significantly. The estimated cost is in the region of 800 million euros, roughly equivalent to, for example, 3 new A380 passenger aircraft from Airbus. The EELT will open totally new horizons for humanity's quest to understand the universe. It will be capable of measuring directly the variation in the rate of expansion of the universe throughout its entire history, providing unrivaled essential information about dark matter and dark energy. It will be able to image extrasolar planets and determine the composition of their atmospheres, and thereby possibly reveal the existence of traces of life. It will peer into the deepest reaches of the universe and witness the birth of the very first stars and galaxies. It may eventually revolutionize our perception of the universe as much as Galileo's telescope did.
One of the most basic aspects of being a scientist is to dare to ask questions. Questions about some of the most fundamental features of our life and of our world. How was the universe created? How and when did the first stars and galaxies emerge? And why did they form? How did our Earth come into being? And are there other planets out there that could host forms of life? One of the most fascinating aspects of being an astronomer today is that, thanks to modern technology, we can now build instruments, telescopes, spectrographs and cameras with which we can really search for these answers. And as we continue in our effort to understand the world, we discover new riddles and new questions. Science gives us the tools to understand and answer these questions.